Small process deviations are costing your company more than you think. A machine runs slightly below its expected speed. An operator skips one step because the process still appears to work. A measurement moves a little outside its normal pattern. A delivery is delayed by only a few minutes. A defect rate increases, but not enough to trigger an immediate reaction. Individually, these deviations may seem harmless. But when they happen repeatedly across multiple shifts, products, teams, or locations, the financial impact can become significant. The greatest operational losses do not always begin with a major failure. They often begin with small changes that become accepted as normal. In this video, we will examine how minor process deviations create hidden costs, why organizations fail to react early, and how Lean Six Sigma can prevent small problems from becoming expensive operational patterns. This is the second episode of Modern Lean Six Sigma: Hidden Failures in Operational Excellence. Large failures are easy to notice. A machine stops. A customer rejects an order. A serious quality problem reaches the market. Production misses a major deadline. These events attract attention because the impact is visible. Small deviations are different. They do not always stop the process. They may not generate a formal complaint. They may not exceed a control limit immediately. The operation continues, so people assume the process is still acceptable. But a process can continue operating while its performance slowly deteriorates. Imagine a production line designed to manufacture 1,000 units per shift. Over time, minor delays reduce output to 980 units. A loss of 20 units may not appear critical. But if the same loss occurs every shift, every day, the annual impact can become substantial. The organization may respond by adding overtime, increasing inventory, accelerating the final stages of production, or pressuring employees to recover the lost volume. The original deviation was small. The consequences are not. One of the most dangerous operational behaviors is the normalization of deviation. A process begins to move away from the expected standard. At first, employees notice the difference. But because the process still produces results, no immediate corrective action is taken. After several days or weeks, the deviation becomes familiar. People adapt. They create workarounds. They change their expectations. Eventually, the abnormal condition is treated as normal. For example, an inspection may originally require 10 minutes. As product variation increases, the inspection begins to take 12 minutes. Then 14. Then 15. No formal change is made to the standard. Employees simply accept the additional time. The same pattern can occur with setup duration, material consumption, scrap, maintenance response time, approval cycles, or customer service delays. The process standard remains unchanged on paper, but the actual process operates at a lower level. This gap between the official standard and real performance is where hidden operational debt begins to grow. The company does not see one major loss. It sees hundreds of small losses spread across the system. Small deviations become expensive because they compound. A minor increase in cycle time reduces capacity. Lower capacity may create overtime. Overtime increases labor cost. Additional pressure may increase errors. Errors create rework. Rework consumes more material and capacity. Delayed production may require premium freight. Customers may receive orders late. A small deviation in one part of the process creates cost in several others. Consider a machine that uses slightly more raw material than expected. The difference may be only a few grams per unit. But if the company produces millions of units, the annual waste can be enormous. The same principle applies to energy consumption. A compressed air leak may appear insignificant. One leaking connection does not seem like a strategic issue. But multiple leaks operating continuously can create a major energy cost over time. Administrative processes behave in the same way. An employee spends only 5 extra minutes correcting incomplete information. That may appear irrelevant. But if hundreds of requests require correction every month, the company is paying for hours of avoidable work. The financial impact of deviation is rarely limited to the visible defect. It also includes time, capacity, labor, energy, materials, delays, lost opportunities, and management attention. Many organizations monitor averages: average cycle time, average defect rate, average productivity, average response time. Averages are useful, but they can hide important changes in process behavior. Two processes may have the same average performance, but completely different levels of variation. One process may operate consistently around the target. The other may alternate between excellent and poor results. The average looks acceptable, but the second process is much less predictable. This matters because customers experience individual outcomes, not averages. A customer does not receive the average delivery time. They receive one specific delivery. A product does not have the average dimension. It has its own measured dimension. Lean Six Sigma focuses not only on average performance, but also on variation and stability. A process that is slowly drifting may still meet specifications today, but the trend suggests that future defects are becoming more likely. If leaders only react after the specification is violated, they are acting too late. The purpose of process control is not simply to confirm failure. It is to detect meaningful change before failure becomes expensive. Not every deviation has the same meaning. Some variation is naturally built into the process. This is known as common cause variation. It may come from normal differences in materials, machines, methods, measurement systems, environment, or human activity. Other deviations come from a specific and unusual event. This is known as special cause variation. A damaged tool, a new supplier batch, a sensor malfunction, an incorrect machine setting, an untrained employee, a sudden environmental change. The response should depend on the type of variation. When special cause variation appears, the organization should investigate the specific event and remove its cause. When common cause variation is excessive, the process itself must be redesigned or improved. A common mistake is to treat every deviation as an individual employee problem. Managers react to each result, change instructions, adjust targets, or demand immediate correction. This can increase instability instead of reducing it. Another mistake is to ignore small signals because the process is still inside customer specifications. Statistical process control helps distinguish random variation from meaningful change. It allows teams to react based on evidence instead of emotion. Many organizations use a reactive threshold. They wait for the defect. They wait for the missed delivery. They wait for the customer complaint. They wait for the machine failure. Only then does the problem receive attention. This approach may appear practical because teams cannot investigate every small movement. But waiting for failure often increases the total cost. A small deviation may be easier to correct early. A tool can be replaced before it produces scrap. A machine can be adjusted before it stops. A supplier problem can be contained before the material enters production. A data error can be corrected before it affects hundreds of transactions. The longer a deviation continues, the more deeply it becomes connected to other processes. Inventory is produced. Orders are scheduled. Customers are promised delivery dates. Reports are generated. Decisions are made using unreliable information. Early detection reduces not only the cost of correction, but also the number of consequences that must be managed later. This is why leading indicators are so important. Lagging indicators confirm what has already happened. Leading indicators reveal what may happen next. Lean Six Sigma provides several methods for identifying small but expensive deviations. Control charts help teams recognize trends, shifts, and unusual patterns before a major failure occurs. Process capability analysis shows whether a stable process can consistently meet customer requirements. Pareto analysis helps identify which small problems create the largest combined impact. Measurement system analysis verifies whether the observed variation is real or caused by the measurement method. Gemba observation reveals workarounds, delays, and abnormal conditions that may never appear in reports. Value stream mapping helps identify where small delays accumulate across the full process. The key is not to use every tool. The key is to select the tool that answers the right question. Is the process stable? Is the variation increasing? Is the measurement reliable? Where is the financial impact concentrated? Which deviation should be addressed first? When teams connect operational data to financial consequences, small problems become easier to prioritize. A deviation should not be evaluated only by its size. It should also be evaluated by its frequency, duration, reach, and downstream effect. When a small deviation is detected, the organization should avoid two extremes. The first is ignoring it. The second is overreacting without understanding the cause. A disciplined response begins with confirmation. Is the change real? Is the measurement system reliable? Is the deviation isolated or recurring? Next, evaluate the impact. Does it affect quality, cost, delivery, safety, capacity, or customer experience? Then investigate the process. What changed? When did the change begin? Which machine, material, method, person, environment, or measurement condition is different? After the cause is identified, implement a focused correction. Do not create a complex action plan for a simple problem, but do not accept recurring deviation without understanding it. Finally, update the standard and monitor the result. A corrected process should become the new expected condition. Without control, the same deviation may return. The purpose is not to eliminate every small fluctuation. The purpose is to prevent meaningful deviations from becoming permanent losses. Operational excellence is rarely destroyed by one event alone. It is often weakened by small deviations that continue for too long. A few minutes of delay, a small increase in scrap, a slight reduction in machine speed, a minor change in material use, a growing difference between the standard and the real process. Individually, each deviation appears manageable. Together, they reduce capacity, increase cost, create instability, and damage customer performance. The most dangerous phrase in operations may be, "It is only a small difference." Small differences become expensive when they are frequent, repeated, and ignored. Modern Lean Six Sigma requires organizations to detect changes early, understand variation, connect process behavior to financial impact, and act before the failure becomes visible. Do not wait for the process to stop. Do not wait for the customer to complain. Do not wait for the financial loss to appear clearly in the monthly report. Learn to recognize the small signals. Because major operational failures often begin as minor deviations that no one believed were important. In the next episode, we will examine why process documentation often fails to change real behavior inside organizations. Subscribe to the channel and continue exploring the hidden failures in operational excellence.